Okay, what's up? This is the last lesson of this unit. It's about absolute value, but it's something different. We've actually dealt with absolute value before. The definition is when you're counting spaces between the value and 0 on a number line. So the absolute value of 3 is 3. The absolute value of negative 4 is 4, because it's that many places to 0 on a number line. Absolute value of negative 6 is 6. Absolute value of 2 is 2. Absolute value of negative 5 is 5. Absolute value of 5 is 5. Absolute value of negative 6 is 6. Absolute value of 6 is 6. Okay. Okay, now here's what we're doing today. Don't worry about this garbage here. Okay, go to the graph. You're graphing absolute value functions. Okay. First, on the first problem, we have to graph y equals the absolute value of x. So we're going to make a table. And we're going to do inputs of 2 through negative 2. 2, 1, 0, negative 1, negative 2. And then just copy what the y equals, which is the absolute value of x. You just put absolute value of x, absolute value of x, absolute value of x, absolute value of x, absolute value of x. So the first x value we have is a 2. How far is it from 2 to 0? 2. Okay. So x is 2, y is 2. So go to your graph and you go forward 2, up 2. Okay, there's your first point. Now put 1 in the x. Absolute value of 1 is 1. So if x is 1, y is 1. So I go forward 1, up 1. Now put 0 in for x. Absolute value of 0 is 0 because you're already at 0. 0, 0 is right in the middle. You don't move at all. I want that point labeled, and you'll see why we labeled it here in a second. Negative 1, so put negative 1 in for x. What's the distance from negative 1 to 0? 1. So negative 1, 1. So we go backwards 1, but I still go up 1. Okay, now put negative 2 in for x. What's the absolute value of negative 2? That would be 2. So backwards 2, but up 2. We do not have a line. We have a V shape. Okay? So take your ruler and just connect the points on both sides of the V. Okay, now this is known as your parent function of absolute values. You can see it makes a V, and it could keep going. See, if you had absolute value of 3, you'd be 3, 4, 4, 5, 5, and if you had negative 3, you'd be up at 3, negative 4. I didn't graph that very well, but yeah, that's how that works. Now, what you're going to be doing today is graphing various absolute value functions, but it looks different than just that. You are not going to be using a table. That takes too long, and it's going to be too confusing. Okay? Table looks great if that's all we have, but we have some other things going on with our absolute value. The key is to find this point here. Once you find that point there, that's known as the vertex, V-E-R-T-E-X. Okay. Once you find that, you can get all your other points easily. Okay. Here's what you're going to write. Okay. When you see an absolute value, you're going to put vertex start. And then down here, you're going to write vertex shift. Those are both coordinates. Both x, y coordinates. Now the vertex start's always 0, 0, but don't graph that. Okay? Don't graph the vertex start. The vertex shift is what we want. Now what other numbers in this? A plus 3. Now it's outside the absolute value bracket, so it's known as a k value. So, if it's a k, here's what I want you to write over here. Put k, and then put next to it, put k values have the same effect same effect to y, okay? So y is 0 here, so that same effect would be plus 3, okay? So you just plus 3 to your y. The x will stay at 0, but on y, 0 plus 3 is 3, okay? The vertex shift is what you graph, so 0, 3. You stay in the middle. You don't go right or forward or backwards, but you go up 3. Now that's your vertex, 0, 3. Now the rest of the points we just go forward 1, up 1, then go back and go backward 1, up 1. Then go to this point right here, forward 1, up 1, backward 1, up 1, and then do it one more time. I want 7 points. Forward 1, up 1, backward 1, up 1, and that's good enough. Okay, please connect them. It's continuous. So there you go. Okay, next problem. Y equals the absolute value of x minus 3. So when you see absolute values that you have to put on a graph, you have the vertex start, which is always 0, 0. And then the vertex shift, which is the one we need to plot. Okay, once again, this is outside the absolute value. After it, it's minus 3, so that's a k value, okay? If it's a k value, it has the same effect to your y, okay? Which would be minus 3, okay? So go to your y and put minus 3 underneath it. 0 minus 3 is negative 3. There's no effect at all to the x, okay? So 0, negative 3. You don't go right or left, but you go down 1, 2, 3. It shifts the vertex down 3 units when you're minusing 3, which makes sense because if I put 0 in for x, the absolute value of 0 is 0, but then when I subtract 3 from 0, I get negative 3. Okay. Then forward 1, up 1, backward 1, up 1, forward 1, up 1, backward 1, up 1. And you see the pattern that forms, okay? And there's your function, graphed. Okay, next problem. Vertex start, which is always 0, 0 from that first graph that we made, but don't plot that because we have a minus 2 outside. Vertex shift. Okay, so what numbers do we have in the problem? Well, we have a minus 2 outside. When we have adding or subtracting as an operation outside, that's a k value, just like it has been on the last two. K values have the same effect to the y. So same effect, if it says minus 2, we'll minus 2 from the y. So 0 minus 2 is negative 2. And that stays at 0. So don't go forward or backwards, go down 2, and that's your vertex. 0, negative 2. So forward 1, up 1, backward 1, up 1, forward 1, up 1, backward 1, up 1. You make your V. You can do that forever. I just need 7 points. The vertex includes one of them. Okay. There you go. Okay, next one. Y equals the absolute value of x plus 5. So you have vertex start, which is always 0, 0. And then the vertex shift. Okay, once again, that's a k value. It's a plus 5. Okay, if it's adding or subtracting outside of the absolute value, it's a k value. How do k values affect the vertex start? Well, it has the same effect to the y. Just put, you don't even need to put value, just put k has the same effect to y. which means I'll plus 5 to the y. Okay. So 0 plus 5 is 5, and that would stay at 0. 1, 2, 3, 4, 5. You don't go forward or backwards, and the V opens upward, okay, from the vertex. Okay. Next one. Vertex start, which is always 0, 0, although that's not the one we plot on the graph, and then the vertex shift. See, that plus 2 shifts the vertex, but how does it shift it? Well, that's why you label it with a K, and K values have the same effect to the Y. K values affect the Y the same way that you see. So if I see plus 2, I'm going to plus 2 to the Y. And then that would stay at 0. Okay, so 0, 2. I don't go forward or backwards, just up 2. Forward 1, up 1, backwards 1, up 1. Forward 1, up 1, backwards 1, up 1. Okay, there it is. 0, 2. Try to remember to label that middle one. Okay, so like this one up here, it would have been 0, 5, just the middle one. Okay, next one, y equals the absolute value of x minus 7. Okay, so again, you have your vertex start and the vertex shift. So 0, 0 is the start, but it shifts because of the minus 7 that you see outside. So vertex shift. Now that is a K value. K values have the same effect to the Y. So if it's minus 7, I need to minus 7 from the Y. 0 minus 7 shifts that vertex to negative 7, and the X stays the same. Okay, so 0, negative 7, 1, 2, 3, 4, 5, 6, 7. Okay. Then do your 1, 1. 7's good enough. If you have 3 on each side, that's fine. Okay. So the coordinate 0, negative 7 is the vertex. Now the game changes on the next page. Okay. This is not, first off, we're going to do vertex start. It's still 0, 0. And then vertex shift. Now the shift is going to be different though. Now the plus 2 is inside of the absolute value. When it is inside, it's known as an H value. What's the difference between an H and a K? Well, 2 things. H values have the opposite effect, not the same effect. They have the opposite effect to the X, not the Y. Opposite effect. So if I see plus 2, the opposite effect of plus 2 is minus 2. And it's to the X. So we minus 2 from the X. 0 minus 2 is negative 2. And then the Y stays at 0. Okay? So you go backwards 2, but you don't move up or down at all. Okay? Then you do your thing. Okay, and then we plot that. So negative 2, 0. Okay, so the H value. Now here's why it's the opposite effect. Because if I put negative 2 where X is at, negative 2 plus 2, if you're at negative 2 and you go forward 2, you're at 0. The absolute value is 0, 0. Okay, so that's why it's the opposite effect with an H value. And the same one here, if you put -1 in for x, -1 plus 2 is 1, and the absolute value of 1 is 1, so -1, 1, okay? And then 3, excuse me, so 1, 2, 3, yeah, if you put 3 in for x, I do that. If you put -3 in for x, -3 plus 2 is -1, the absolute value is 1. So that's how that works, okay? Next one, that's an h value, so vertex start and vertex shift. Okay, 0, 0 is always the start. Now an h value has the opposite effect to the x, okay? So it's -6, the opposite effect would be to +6, and it's to the x. So you go under the x and +6. So 6, and that would stay at 0. So I go forward 6, 1, 2, 3, 4, 5, 6, and just stay on the x-axis because you don't go up or down. So 6, 0. Again, the reason it has the opposite effect, because if you insert 6 in for x, what's 6 minus 6? 0. Absolute value is 0, 0. Okay. Alright, next up. Oh, that's an h value. Okay. So vertex start and vertex shift. So the starting point of the vertex is always 0, 0, but then we have to coordinate our shift. H has the opposite effect to the x, okay? So it says -3, so I'm going to need to +3. 0 plus 3 is 3. And then the y stays at 0. Okay, 3 minus 3 is 0. Makes sense. So I go forward 3, stay in the middle, and you just fill out the rest as at least reasonably. Okay. Alright, that's another h value. So you have vertex start and which is always 0, 0, and vertex shift. Okay, so that +1 shifts the vertex. What's an h value? H has the opposite effect to the x. Okay, so if it's +1, I'm going to -1. So 0 minus 1 is -1, and the y stays at 0. There's no effect to the y because there's no plus or minus outside the absolute value. So I go backwards 1, stay in the middle. Okay. Forward 1, up 1, backwards 1 up, forward 1 up 1, backwards 1 up 1. Okay. There's your shift. Okay. Okay, next one. Y equals -x plus 4. Now, I'll talk about the negative here in a bit, okay? But that's a k value, okay? So again, you got vertex start and vertex shift. 0, 0 is always the vertex start. Now, what's a k value do? K has the same effect to the y. So if it's +4, we +4 to the y, okay? Go under your y and +4. So now y is now 4, 0 plus 4 is 4, and then the x would stay at 0 since there's no h value to translate that, okay, to shift it. So 0, 4, I don't go forward or backwards, just up 1, 2, 3, 4, 0, 4, forward 1, up 1, backwards 1. Okay, and there's my, oh shoot, gosh! Guys, I screwed this up. Cross that out. I want the vertex still, but I messed that up. Dang it! Okay? When you have a negative there, you're going to go down 1, forward 1. That's what a negative does. It turns it upside down. Okay? Shoot! So watch that. So it's going to be down. So forward, down. Backward, down. So we go down instead of up. The V opens downward. Okay. Dang it. Okay. Next one. Okay, that's an H this time. What do H's do? They have the opposite effect to the X. So I see plus 2. We're going to minus 2 to the x. So again, the vertex start and the vertex shift. And we do have that negative there. So that put a down arrow. Put a down arrow so you can remember it. That means you'll get your vertex the same way you always do, but you'll go forward down, backward down. Okay? Okay, so 0, 0 is the start. Opposite effect to the x, so it's minus 2 to the x. No effect to the y because there's not a k right there. So I go backwards 2 right there, and let's see if your idiot teacher can do it right this time. You're going down and forward, down and backwards, down, forward, down, backwards, down, down. Okay, it just shifts everything. Okay, then that negative 2, 0 is your vertex. Okay, 2 left. Ooh, we have an H and a K here. Okay, so what's an H do? Opposite effect to the X. So what's the opposite of plus 4? It'd be minus 4. Now the K has the same effect to the Y. So you see minus 2, it's minus 2. That's why it says same effect, not the opposite. So vertex start and vertex shift. 0, 0 is your vertex start, okay? Now, opposite effect to the x. So we need to minus 4 from our x. 0 minus 4 is negative 4. But the k has the same effect to the y, which would be minus 2. See? So they both are affected, and that's your vertex. So you go backwards 4, down 2. 1, 2, 3, 4, 1, 2. So negative 4, negative 2. And there's no negative, so it's up, okay? Up, forward, up, backwards, up, forward, up, backwards. And there you go. Now the reason why this makes sense, because if I would substitute negative 4 in for x, negative 4 plus 4 is 0. Okay, the absolute value is 0, 0, but then when we subtract 2 from 0, we're at negative 2. Okay. So some of you are saying, well, that doesn't make any sense that you do the opposite to x, but the same to y. I just showed it. If I put negative 4 in for x, negative 4 plus 4 is 0. Think number line. If you're at negative 4, you go 4 forward, you're at 0. Absolute value is 0, 0, but then when you subtract 2, y ends up being equal to negative 2. Okay? Alright, that's an H, that's a K. So the H is going to have the opposite effect to the X. So if I see -2, we're going to +2. And the K has the same effect to the Y. Same effect means it's +3, so I keep it +3. And also I've written it down on the board too. Vertex start, which is 0, 0. But that's not the one we graph. The vertex shift is the one we put on the graph. So how is the X affected? Well, we're going to +2 to it. 0 + 2 is 2. How is the Y affected? Well, +3. So 2, 3. I go forward 2, up 3. Then there's no negative, so it opens upward. So up, forward, up, backwards, up, forward, up, backwards, up, forward, up, backwards. Okay. Label that 2, 3. Okay, you got 4 to do. Okay. Number 3 has the negative, so that'll open downward.